What's up, everybody? Just wanted to walk you through this set of notes. This notes is specifically going to deal with ions. So what you're looking at right now is a periodic table, but it's what we call the periodic table of ions. So as you can see, it has elements similar to what you would regularly see on the periodic table. So here's hydrogen, and there's its atomic number right there. Here's helium over here with its atomic number. It doesn't give you atomic masses or anything like that. We're concerning ourselves here with both the number of protons and the number of electrons, and because that's what makes an ion. So the first thing I want to do is you'll notice in the little packet that you got, you have both, you have your periodic table of ions on the front, and then you have a couple of blank pages behind it. And the blank pages are there for you to take notes. And so we're going to go ahead and do those notes. You can go ahead and flip to the second page. It should have a blank page just like you see here, and I'm going to go through. I'm going to tell you some things that I'd like you to write on this page as you go through these notes. So the first thing I want to do is I want to go ahead and define what an ion is. So you did some reading on ions the other day in class, and I want to make sure that we're clear on some of the things that the reading tells you. That an ion is an element with either, and I apologize for my handwriting, I'll do the best I can to make it as legible as possible. It's an element with either more or fewer electrons than it normally has. I didn't write normally very well. There we go. So that's the first thing we do. We define the ion. It's an element with either more, oops, forgot my E, or fewer electrons than it normally has. And we get ions when certain elements take or give electrons from their valence. So let's go ahead and write that down. We get ions because not every, for the most part, we have ions of every element, but some of them are much more likely to become ions than others, and others will simply just share their electrons. So they won't give or take, they'll just share their electrons. So we get ions when certain elements take or give electrons. And specifically from their valence. So the only place these electrons are coming from is the valence. We know that all elements have a number of shells, either one shell or 7 shells, but those electrons that are being given or taken are only being given from the valence or taken and put onto their valence. So these are the 2 points that we want to make sure that we are clear on. Okay. Now, what I want to do is I want to talk about, let's go ahead and take a minute and let's talk about how something becomes an ion. Okay. Now, there's 2 types of ions. Okay. The first is what we call a cation. And the second is what we call an anion. That's supposed to be an A, okay? So these are the 2 types of ions. We have cations and we have anions. So what we're going to do, we're going to take a second and we're going to talk about how these two things form, okay? So let's go ahead and go to the next page. And on the next page, we are going to look at the compound NaCl. And this compound forms from 2 ions, okay? And we have one of these that is the cation and one that is the anion. All right, so the first thing we're going to do is we're going to do some memory stuff here. So we're going to start by remembering that the element sodium is Na, and if we look at the periodic table, we go back to our periodic table here, and we look, we see that sodium has an atomic number of 11. So that's what we're going to go ahead and write right here. Okay, it's got, make sure I have the right ink. I do. It has 11 protons. Okay, and if you remember, that means it's in the nucleus. It's got 11 protons. I did a crappy job of, here we go, 11 protons. The P stands for protons. Okay, now I'm going to go ahead and put that over here, that we have 11 protons. And if you remember, you guys, protons have a positive charge. Okay, now let's go ahead and remember, based on what you know about protons and electrons, we know that sodium also has 11 electrons, and those electrons are negative. Okay, so if we were to add this up, if we were to add positive 11 plus negative 11, we know that the overall charge is 0. So in just regular good old sodium, there's no charge because this is balanced. You have 11 protons balancing 11 electrons. There you go. So let's go ahead and draw our Bohr model of sodium. So I'm going to go ahead and draw, let's see, I'm going to take we'll use a nice purple color. So we're going to draw this in purple. And you guys, as you're doing these notes, I really want you to use the same colors that I'm using. I think you'll find it helpful. All right, so if you remember, on our first shell, we're only allowed to have 2 electrons. So I'm going to put 1 electron here and 1 electron here. So again, you guys, I still have a bunch of electrons I have to get on here, so I'm going to go ahead and draw some more shells. So we're going to need another shell. Let's draw another shell. And let's go ahead and remember, from our last couple of units, we know that our next shell can hold 8. So let's go ahead and put 8 on here. 1, 2, 3, 4, 5, 6, 7, 8. And if you recall, we need a total of, now right now if we count these up, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're almost there. We've got to do one more shell because we have to get one more electron. So let's go ahead and draw our last shell, snug that up a little bit, and let's go ahead and that will be our last shell, and let's put our last electron right up here. Okay, now, if you recall, the octet rule that we talked about the other day says that in order for any element to be quote-unquote happy, it means that it has to have a full valence. And a full valence for any element other than hydrogen or helium is 8 valence electrons. And right now, look at poor little sodium. It's only got 1 valence electron all by itself out here, so it's really unhappy. Now, there's a couple things that could happen here. You say to yourself, well, if we wanted to make sodium happy, we could get rid of this, or couldn't we just go out and get 8 more electrons? Well, here's the problem with the second suggestion, is that it takes a lot of energy to get electrons. And as a result of that, if sodium has to go out and get 7 more electrons, it simply does not have the energy to go make that happen. So as a result of this, it's actually easier for sodium just to get rid of this electron rather than gathering 7 more electrons. So sodium, which has a fairly low electronegativity, will be can easily get rid of this electron, so that's what it does. It teams up with something else. In this case, it's going to team up with chlorine, and it's going to give this electron away. And once that happens, let's go ahead and show you what happens. Once we get rid of this electron, that entire shell basically doesn't exist anymore. So what happens is that this shell right here, this second shell, actually becomes the valence. And if we look at the electrons on it, look, there's 1, 2, 3, 4, 5, 6, 7, 8. So now, you guys, we don't have the element sodium anymore. We have what's called sodium ion. So this is now called sodium ion. And the reason it's an ion is because now, you guys, if we look at this, the nucleus still has 11 protons. So let's go ahead and write that here. Sodium ion has 11 protons. And remember, those protons are positive. But now look at the number of electrons we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now we have 10. Oops, I did that wrong. We have 10 electrons, and remember those electrons are negative. And so if we were to add those up, we would have plus 10 and negative 11, so we have plus 11, and then we have negative 10, which means that we have one extra electron now. That's why this is an ion. We have the same number of protons, so it's still sodium, but now we have a different number of electrons. We only have 10 electrons now. That's why this is sodium ion. And it carries an overall charge of +1. So that when we write sodium ion, we would write Na and then a positive next to it. We could also write it like this, positive and then Na. You see it both ways on the periodic table, so just know that you could see either one of these and it would still be correct. So this tells us a couple of things. A, it tells us that it's still sodium, and it tells us that it has an overall positive charge. So this is a cation. So we talked about there being two types of ions. Sodium ion is a cation. And that means it has an overall positive charge. Another way of saying this is that you have more electrons oops, I did that wrong. You have more protons, sorry about that, than electrons. Okay? So we form a cation when our element gives away electrons and we end up with more protons. In this case, we have 11, and fewer electrons. We only have 10, so our overall charge is positive, which makes sense because protons are positive. So that's how you make a cation. I'm going to go ahead and highlight cation so we know that that's what we're dealing with. We'll just do it in green here, which is a lovely color. Yay, cation. All right, so now let's talk about, so in our equation NaCl, Na is the cation. So what we have to do now is we have to talk about how chlorine forms, because chlorine is going to be our anion in this compound. So let's go ahead and go to our next page and let's do something similar. Again, we are still dealing with NaCl, our compound, and we're going to do pretty much the same thing. Now, if you recall, this time we are dealing with chlorine. So let's go ahead and draw the nucleus of chlorine. Remember, chlorine is Cl, and if we look at our periodic table of elements, we can remember that chlorine is right here, and it's got an atomic number of 17. And if you recall, that means chlorine has 17 protons. We're going to go ahead and put that little positive sign there because remember, protons are positive. All right, so we're going to go ahead and draw our nucleus around that. Look, I have a little oval nucleus. Never done that before. Anyway, we'll just make it work. Okay, so now what we're going to do is we're going to draw, again, our shells. Now, remember, you guys, let's do this first. Let's go ahead and recall that if we're dealing with chlorine, we have 17 protons, which are positive, and we have 17 electrons, which are negative. So chlorine, the element of chlorine, has 17 protons and 17 electrons. So let's go ahead and make a drawing of that. So let's go ahead and do our first shell. And let's go ahead and make these blue. So we've got 2 protons on our first layer, first shell, I guess. Let's go ahead and draw another shell. And if you recall, our second shell always has 8. And again, you guys, you're drawing this right along with me. This becomes a really handy set of notes. This is when we start talking about ions on a quiz, you're going to want these notes. So let's go ahead and draw our 8 electrons on our second shell. There they are. Now remember, we have a total of 17 electrons. So far we've drawn 10, so we're going to need another shell. Let's go ahead and draw that up. And I'm going to put, I have 10, I need 7 more electrons. 1, 2, 3, 4, 5, 6, and 7. Now, again, you guys, remember our octet rule. Our octet rule says that we have to have 8 in order for chlorine to be happy, and we're not there yet. We only have 7. That makes chlorine really reactive. Chlorine will work really hard to get an electron from somebody else. It's going to take an electron from something else, and it works out because we know that sodium has 1 electron to give. So these guys start to pair up together, and what happens is that sodium will go out and it will get that electron from chlorine. And now if we look at chlorine, we see that now it has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. So now chlorine is happy. But again, you guys, if we go and take a closer look at chlorine, it still has 17 protons. So chlorine, because now what we've done here, you guys, we've made chlorine, oops, I didn't want to get rid of that. Looks like this is now chlorine ion. Okay, and what that means is that this still has 17 protons, and those are still positive. But now if we count these up, we counted out that this has now 18 electrons, and those electrons are negative. So if we do the overall charge, 17 minus 18 is essentially minus 1. Okay? So what that means in this case now, we now have an anion. Okay? An anion means that, wait, what did I write here? I gotta double check. The overall charge is negative. Okay. So if we write chlorine ion, we're going to write it as Cl negative, or either one of those is true. So what that means is that if I have Cl, it means this is, so the 1 is implied, and what it means, that tells you how many more electrons you have than protons. So we have an overall charge that is negative. That means we have more electrons than we do protons. So let's go ahead and highlight that. We'll go ahead and make this nice yellow color or whatever. Okay, so yeah, you guys, an anion means our overall charge is negative. It means that we have more electrons than protons. In this case, you guys, if we are looking at NaCl, it means that sodium gave away an electron and chlorine went and got that electron. All right, so that's pretty much a little tutorial of how anions and cations form. Remember, by definition, an ion is an element with either fewer or more electrons than it normally has. We get it when certain elements take or give electrons. Again, those come from the valence, and we've got 2 types of ions, cations and anions. Now let's go back to this, our periodic table of ions, because this is going to be something that's really helpful to you. Okay? And what we're going to do is we're going to do a little bit of color coordinating on this. All right? Now, you'll notice if you are looking at this that you've got these plus signs above our columns. So where we have these plus signs or negative signs above our columns, it means that pretty much everything in that column follows the same rule. For instance, and let's go ahead and put this in yellow. Oops, actually I want to highlight it in yellow. Let's do that. There we go. Oops, did that. So what that means is that everything in this column has a charge of +1. Everything in this column has a charge of +2, because that's what it tells us right up here. Okay, I'm going to go ahead and color those in as well. And I would love it if you colored these in because I think it's helpful. Now, the reason that we don't spend a lot of time coloring this is that these elements right here in the middle, these are kind of a free-for-all. They're a little bit all over the place. Some of them will bond ionically. Some of them will bond covalently. It's kind of a little bit of a free-for-all. You can kind of see right here that these have different charges depending on which version we're getting. It gets messy. So when we're dealing with these in like chemical equations, you'll always be told which one is it. Is it if it's iron and it's got a charge of +3, or if it's iron and it has a charge of +2? Like I said, it can get kind of messy. All right, so let's go back here, because this column as well, the boron family. So your alkali metals, they are willing to, they can give away they have one electron to give away, so they're going to do it. This next column, this is the alkaline earth metals. They have 2 valence electrons that they can give away. The boron group has 3 electrons that they can give away. Now this is where it gets tricky, you guys. After the boron group, things sort of change. Now just understand this, it takes a tremendous amount of energy to give away electrons. The more electrons you have to give away, the more energy you need to give them away. Once we get up above 3 valence electrons, what happens is that you need more energy than is possible to give those away, and as a result, you end up not giving them away. So you have this group right here, and I'm going to go ahead and paint this group, we'll just say a blue color, because this particular group right here, this is the carbon group, they don't make ions, all right? These tend to just share their electrons covalently, but they don't give them away. So when we start talking about ionic bonds, you won't see this particular group right here in those ionic bonds. You usually see these groups right here making ionic bonds, and these groups right here making ionic bonds. So let's go ahead and highlight this next little group here to make it pink. These 3 right here, notice these groups, you guys, they have negative charges. And so this group, these 3 groups right here, we have the nitrogen group, the oxygen group, and the halogens. They are looking to take electrons. All right, so the nitrogen group takes 3 electrons, the oxygen group will take 2 electrons, and the halogens will take 1 electron in order to fill their valence. So let's make a little, and what that number tells you, what this number tells you is how many they're going to take. This number tells you how many each group is going to give away. So let's go ahead and make a note. So that if you're highlighted in yellow, if it's a highlight in yellow, it's going to take electrons. I'm sorry, if it's highlighted in yellow, it's going to give electrons. My bad. And I'm just going to make that a big E with a minus sign. And if it's highlighted in pink, you're dealing with elements that are going to take electrons. Okay. And if it's this particular group right here, the carbons, they're not going to do anything. They're going to bond covalently. I'm not going to write that on here. I just want you to understand that if it's in the yellow, it's giving electrons. If it's in the pink, it's taking electrons. And everything else we've kind of left up in the air because it's a little bit, it's a little bit crazy. Now, the one that doesn't really do anything is this last group here. I'm going to put that in green. These are your noble gases. These noble gases, you guys, they're not giving electrons. They're not taking electrons. They have a full valence. So nothing's going to happen with these. They're non-reactive. And I'm just going to put a little note right there. This is a full valence. Full valence, and those elements aren't going to do anything. So that's what that means right there. All right. So when we take a quiz about ions, I want you to have this sheet in front of you. Again, you have your periodic table of ions, you've got a couple sets of notes, and you've got explanations for how we make both cations, which have an overall positive charge, and anions, which have an overall negative charge. Okay, that's it. Good luck.